Alright, so I'm going to go over the components I selected to build a T-Rex 470 with a rotor flight controller. I went with the Tiny Talon 16x16 and followed one of the setup guides pretty closely. This is what they recommended for a servo tail. And I'm wired up pretty much exactly like this, except I have a RPM signal going to TX3. And this is how I wired it. Here's the RPM that's not shown in the wiki, and that was pretty easy to add in just through the spreadsheet that they use. These wires, they don't go one to one. This one doesn't go to this pin, and that one to that one, and that one to that one. I had to run through the multimeter and put them where I wanted them. But, it was a pretty clean little servo pin header I robbed from another receiver. It worked well. The receiver I'm using is a Maytech Express LRS with the diversity antennas. And I'm running an open logger because the Tiny Talon 16x16 doesn't have the black box. The 20x20 Talon does, but the smaller one does not. And this one, I'll run a few gigabytes on an SD card, and that'll be a lot more convenient than a few megabytes of built-in flash where you have to hook up to the computer after every flight. For the speed control, I went with the 60 amp Platinum Pro V4. It's got the RPM sensor built in. It also goes to 8 volts on the BEC, high current BEC, and that will be supplying the Tiny Talon. Tiny Talon goes from 2 to 4S voltage input, and that will be enough to run it. The only thing I'll be using on the BEC of the Talon itself will be the ELRS receiver at 5 volts. For the servos, I'm running KST 215s. They're high voltage servos, and they're pretty quick. They run at up to 333 hertz, which is the default for rotor flight. And metal case and metal gear. Hopefully survive a few wrecks. Alright, so here's everything all mocked up and test fit. A little 3D printed bracket on the pin header, using the supplied flight control mount with the T-Rex 470 kit. I think it's fiberglass, so I don't get any continuity through it with the multimeter, stabbing it with the probes. The receiver is just glued on with some E6000. Again, I don't think there's any continuity on that board. I think it's a little fiberglass piece. Got a smoke stopper wired in just in case. They won't stop everything, but they'll keep you from doing damage in a lot of scenarios. Got the servos mocked up and marked. I'll mark the side I want to center the arm on so I can come back later in the configurator and center up the servo arms and sub-trim them. Alright, so I'm going to add the rotor flight configurator onto a new machine where I'm trying to do all this video recording and editing. Go on to the wiki and download the snapshots configurator. And this is release candidate 1. At this point, this is the newest. It's 19 days old. And working on a Windows machine. Windows is trying to protect my machine. Alright, so here's a brand new install of release candidate 1 configurator. I've already set up the flight controller on this helicopter, but I've got another one, exact same Tiny Talon, that I'm going to put on an OMPM one later. But just for now, I'll use it to demonstrate flashing the firmware on a brand new flight controller that still has beta flight on it. Alright, so I'll plug this little guy in. Alright. Alright, it's telling me that it's the wrong kind. It's still got beta flight on it. I'm not sure if the command line will let me kick it over into DFU. I don't even remember the right command. Alright, so I'm going to install the beta flight configurator, which should be able to kick it over into DFU mode with a little button. Again, Windows doesn't want to, but I do. Alright, there's the beta flight configurator. Gonna cycle the USB. There it is. That kicks the board over into DFU mode for firmware flashing. But we're not going to flash firmware in beta flight. We're going to flash in rotor flight. And we're looking for the Tiny Talon F7. Which is, I believe this F7V2. We can verify that. Yeah, Talon F7V2 is the beta flight target, which will be the same as the rotor flight target. There's release candidate 1. We'll load firmware online. We'll do a full chip erase and flash firmware. It doesn't like it. We're already in bootloader. It's reload rotor flight. Ah, there we go. No response from bootloader. So let's find the impulse RC driver fixer. Right there. Okay, it's still working, but it's done the important part already. Rotor flight sees the DFU. So now we've got Tiny Talon F7 V2, release candidate 1. It's the only option available. Let's go ahead and load it online again, even though I'm pretty sure it's the same thing I just did. And flash firmware. There we go. Okay. So it has flashed. Now we're going to hit connect. It should have applied custom defaults. Let's try that again. Oh, no custom defaults. Did I do something wrong? I did something wrong. For some reason it sees data flash. There is no data flash. Cycle the power on this one. There we go. Apply custom defaults. Now it sees it. Go ahead and hold it fairly level and calibrate the accelerometer. All right, everything's moving right. All right. So that was a bone stock Tiny Talon F7. It had beta flight on it. Now it has rotor flight on it. I'm going to disconnect it and run through the spreadsheet. All right, from the rotor flight wiki, we're going to go down to the default remapping spreadsheet. Now this is the view only mode. You'll need to make a copy with your own Google account. All right, and they assigned motor 2 as frequency. Oh, this is the wrong board. Switch to an F722 and the Talon F7B2. Motor 1, let's go ahead and get rid of all of this. Change them all to none. Our default. So now motor 1 is going to be servo 1, motor 2, servo 2, motor 3, servo 3, motor 4, servo 4. The LED strip is going to be motor 1, and then TX3 is going to be frequency. And this is just how I wired mine. TX3. And set that to frequency. Now I have the available timers over here. Motor 1, I left on timer 1. That's AF1. This column right here, select AF1 to put it on timer 1. Now all of the servos I did on the AF2, so they're timer 4 and timer 3. That puts all of the cyclic servos on timer 4, and then the tail servo on timer 3. That's not important now, but having the tail servo separate might be useful in later releases of rotor flight. So servo 4, we're also going to do alternate function 2, and then frequency, timer 2, nothing else is using timer 2, so we'll put that on AF1. And you go down here and you see you don't get any warnings. Like say, if I put motor over here on 2, that's timer 3. The rudder servo is using timer 3, so the spreadsheet's going to warn you not to do that. Let's go ahead and put motor back on AF1. And the conflict's gone. This is how I have the other flight controller set up. It's already installed in the bird. So just go in here, hit shift, and select all through here, and you copy it. And you go into rotor flight and connect you go into your CLI and you paste everything you just pulled out of the spreadsheet. Hit enter. Then type save and hit enter again. So now, you go down into your servos, you'll see your servos. These all used to be your motors when this was a drone flight controller. And now is a decent time to go into the mixer. Just regular old clockwise helicopter. Swash plate type. The 470 has the elevator servo in the rear. 120 degrees CCPM. And we are doing a variable pitch tail. And we'll save. And that's the point that the other flight controller I have in the 470 already mounted. That's where that one is at. This one I'll reprogram later for a OMPM1. So it'll be using a motorized tail rather than servo tail, but a lot of the layout will be the same. No frequency sensor because it'll be using BL Heli. But just for demonstration, I went ahead and went through that process again. Alright, so I've updated the Express LRS receiver, set my bind phrase. Again, if you need to learn how to do any of that, Joshua Bardwell's recent video is very thorough and very good. Go ahead and watch that. I'll put a link in the video description. So I'm going to go ahead and connect. And you can see I haven't set the accelerometer. Haven't set the board alignment, rather. I'll come back and do that later, and I'll need to recalibrate the accelerometer after I've got the flight control mount with both sides of the frames on so the actual board is level. But for now, I'll come back to that later, and for now I'm going to go to the receiver tab. Or first I need to go to the serial ports tab, and I set my receiver on UART 5. So set UART 5 to serial receiver, save and reboot. And now I'll go into the receiver tab. Turn on my transmitter. It's a TX16 running a module.
I don't really care anyways.
Running a sound pack from a video game. Alright, so Serial RX, Crossfire. Oh, my receiver has gone into Wi-Fi mode. I was sitting there thinking about it too long. So I'll have to cycle the USB, which is powering the receiver. Did not know the Tiny Talon put out the 5 volt through the USB. So go ahead and cycle the USB. Alright, over to the receiver tab. Now I've got the receiver function. I got set the serial port. I put it on UART 5, set that to Serial RX. Then in the receiver tab, set Serial RX. I believe that's the default. And then you set the protocol to Crossfire. And your channel map for, if you're using Express LRS, you will have to put your first auxiliary as the 5th channel, because Express LRS treats that as always being your arm switch. And it's best to oblige because that's only a 2-position switch. So you put your throttle on the 6th channel and you can set it to wide mode through the Lewis script on the transmitter. And that gives you 128 positions on throttle, which should be enough. You can adjust your governor to match whatever you want, and 128 position will be plenty on throttle. And there's the receiver tab. See it's reacting to my controls. Go ahead and bring in some video of the helicopter and transmitter. So, got the solid light on the crossfire receiver. We are plugged in USB into rotor flight, and we've got the transmitter operating like it should. And then pitch is on the throttle channel. I believe that is something I'll have to change up in the model memory on the TX16. That's in the programming there. I copied another helicopter, and it'll need some fine tuning. Well, that's the receiver working, and you will have to set your model memory to match what rotor flight expects. Aileron, elevator, collective, rudder, auxiliary 1, throttle, and then auxiliary 2 and 3. And you can use those to set up your modes. It should be plenty to do almost anything you want. Set up a recovery, set up self-level, set up bypass. But yeah, that's the receiver tab with an Express LRS receiver. I have not actually done the helicopter yet on Express LRS. I've had one quad set up on Express LRS, so I will be figuring this out a little bit as I go. Alright, so I'm going to go back into configuration, or rather system. And this won't be perfect. I'll have to come back and redo the calibration of the accelerometer later. Right now the flight control mount is sitting at half the frame and it's not perfectly level. So I'm just going to eyeball it level and calibrate the accelerometer. And now you can see the helicopter is sitting upright. But you can see as I move the helicopter, it's not reacting right. So I'll need to go into configuration and rotate the board alignment. And I'm just going to guess, we're going to roll it over 180 degrees and save it. Okay, we're not quite there yet. I think we'll need to rotate the yaw 180 degrees. Maybe 90. Let's try 90. All right. That was not it. So we'll do 180. This board doesn't have an arrow on it. I forgot what direction it was going. Usually there's a little arrow silk screened on it. Okay, pitching forward. Roll and yaw. So there's our board alignment. That's not the best way to do it, just guess and check, but it did get us there. And add the roll set 180 degrees. The board's mounted upside down. And then the yaw around 180 degrees to get the pitch and roll axes lined up right. Features, frequency sensor, yes. We will use the governor and telemetry. It'll give us voltage from the BEC from the speed controller, not the battery voltage, which could be done if the flight controller could do 6S, but it can only do 4S, so I'm running the flight controller off of the BEC rather than the battery voltage, so the telemetry doesn't know what the battery voltage is. We'll do an RPM filter and save and reboot. All right. So I think we're ready to plug in servos and try them out. All right, so I've got servos plugged in, got elevator into channel 1, the left servo plugged into channel 2, and the right servo plugged into channel 3. Still plugged into the smoke stopper. And go ahead and connect and enable servo override. Go down into the servo menu. And I'm working with, you can see right now, the servos are reacting to the gyro. So you go into servo 1, 2, and 3, and now they're all locked at 1500 microseconds. Rudder's still not plugged into anything, so I won't bypass it yet. All right, moment of truth, plugging in power to the servos. And I have no idea if those arms are even on close to straight. I need more hands. That one's 180 degrees off. I put this mark on here to show the angle I wanted to put the arms to. Set this up here. And just pick the spline closest, trying to get 90 degrees. You won't get perfect 90. The splines don't always line up right. You could see it'd be nice if it go that way, but you go to the next spline and it's too far the other way. They're pretty even. You could probably choose either of those two splines. There is the left servo, which, yep, it is responding to channel 2. And this servo is the right servo. That'll be channel 3. Wasn't too far off on that one, but we'll move it over a spline. And it is responding channel 3. Now we've got the elevator servo, the rear one, and it is pretty close. I'm not even sure it's worth moving it. We'll see what it looks like. Yeah, it seems to be the closest one. Lined up with the mark I made, at least close, and I have to use sub trims to get it to get a little bit closer. Right now I don't know if the directions are set right. One of them will have to be reversed, or two of them will have to be reversed, and one will be normal. I'll mock them back up in the helicopter and give that a shot. Really should trim this servo arm before I do this. Let's go ahead and mock up the two front ones. They don't interfere with anything. Okay, it's the left servo. This is the right servo. And this is the elevator servo. Just lined up, I'll be able to see what direction it's moving. There we go. Now you can see all the servos. I'll go ahead and make any changes to save. So I'll go ahead and go back up to System and enable Mixer Override. Go into the mixer, enable roll, pitch, and collective. Now we take the collective and we're going to go up. Too much current. The smoke stopper limited it. So we've got the elevator servo going down, the left servo going down, and the right servo going up. So there's a good chance we'll want to reverse the right servo. Let's recenter that. Yeah, reset the speed control again. I'm going to roll. Rolling to the right, so the right servo is going down like it's supposed to. So I believe that means we want to reverse left and elevator. Let's go back up to System, disable Mixer, go back into Servo Override. Back to servos, and reverse 1 and 2, and save. That's elevator. Oh wait, no, excuse me. Did that wrong. No, I did that right, I think. Alright, I didn't need to disable the mixer. It's saved. Back to System, and enable Mixer Override. And roll, pitch, and collective. So, all them working right? Well, close to right. That rolls the swash plate to the right. And on the elevator, we are pitching the elevator forward. Now we move the collective, they're all going up. So the servos are set the right direction. My speed control keeps resetting because the smoke stopper is limiting it. The servos are drawing enough current to drop the voltage. See if I can move it and see a little bit of flash of light. Yeah, you see a little flash of light right there? That's the smoke stopper doing what it's supposed to do. When you draw too much current, the smoke stopper limits it, and the servos are enough to do that. And it's resetting the speed control, but it's not really causing any harm that I can tell. Go ahead and recenter. So there's the servo direction set right. Now we can go in and sub-trim the servos. Need to go back to System and enable servo override. Alright, so here's the elevator servo. Need more hands. Alright, there's the elevator servo. Go back to the servo tab. This is servo 1, the elevator servo. And we'll enable it. That locks them at 1500. And then we use the trim to center this as close to 90 as we can. That was the wrong way. Getting closer. That's pretty close right there. That's just the eyeball. And that's good enough for demonstration purposes. I probably will fly it that way too. Now, try to do the left servo, which is channel 2. We are trying to get it to 90 degrees to the servo body. That looks pretty good. And then, so we can flip around the helicopter without disconnecting anything. Last servo, the right servo, channel 3. Oops. I accidentally got that right. A little too far, maybe. Yeah, I think a little too far. That's pretty close on the cyclic servos. So now we hit save. And there is the servo, the mixing, and the sub trim. And you can see with these bypass, the sub trims now register on these 3 servos. There's a 50 trim, so that's 1550. 56 trim, it's 1556. These two are reversed, that's why that seems backwards, why a negative number added to it. And this one is negative 42, and it was not reversed, so you can see that it subtracted 42 from the 1500 microsecond center. Those are the cyclic servos. The tail servo will go basically the same. I haven't mocked up the tail servo on the helicopter yet. This is a common practice on all flight controllers. You always want to do your sub trimming in the flight controller, never in the radio. If you're putting 1550 out on the radio, then that means you're telling the flight controller to move. If you're giving anything other than the recognized center pulse width, it sees it as a command. So you always want to do your trimming in this menu. If you're in auto level and it's drifting, then you want to use the accelerometer trims. Never use the radio trims. You can disable them if you want in the radio. That's probably a good idea. But that's not just rotor flight. That's all flight controllers. I really like rotor flight servo setup. Fairly intuitive. Assuming I did it right. This is all me following the wiki and trying to figure it out on my own. Oh well, this is new for release candidate 1. your servo update rate, that used to be a CLI command. And you can see it up here. You can set it to 333, which is the default, which is what my servos want. But if these are analog servos, you could set them to 50 and then save it, which I don't care to because these are digitals that can work up to 333. So let's go ahead and check and see if everything's saved. Disconnect. Cycle the power on everything. Go ahead and disconnect the USB at the computer.
Telemetry recovered.
Now we can go back into the servo tab and see that it did save my subtrims. And some of the early configurators, I had issues where it wouldn't save the subtrims. And it seemed to be whether or not you had the overrides enabled. Go ahead and turn the overrides off and you'll remember what your subtrims were, and then go back and put them in again. But, it seems to be fixed with release candidate 1. And I'm not entirely sure. It wasn't me just screwing up before. It just seemed like a thing that happened a couple times. I never documented it. Never tried to replicate it. But this worked perfectly on the first try. Release candidate 1. That's awesome.